Okay, so for identifying function graphs, number 3, the data below represents a relation between the input and output. So part A says write the ordered pairs for each input shown above. Guys, for your Savas assignment tomorrow, I'm showing you how you have to type in your ordered pairs. So I always like to start on the left. What's the ordered pair for this point?
Negative, 4.
Negative 4, 4. So I'm gonna put parentheses, negative 4, comma, 4, parentheses. Just like it says on the board. Now, what's the ordered pair for this point?
Negative 3,
Negative 3, negative 3. So I'm gonna put comma, and then I'm gonna write down my ordered pair. If you do not put commas in between your parentheses, Savas will not take it. What's the ordered pair for this point?
Negative 2, 4.
Negative 2, 4. So I'm gonna put comma, and then I'm gonna write down the ordered pair for that point. What's the ordered pair for this point? 4, 4. Positive 4, 4. Thank you. And what is the ordered pair for this point? 5, negative 2. Make sure you put parentheses or commas in between each set of parentheses. If you don't, Savas will not count it. Okay. Does the create a function map to represent this relationship? So I'm gonna start off with an oval. Another one, mine looks more like zeros. Make sure you give yourself some space in between them. Do not put them straight together. The numbers that go in this oval, is this gonna be input or output?
Input.
Input, label it. And is that the X or Y?
X.
X. The numbers that go in this side, is this gonna be the input or output?
Output.
Output, label it. And guys, whenever you actually see a relationship map, they're not gonna have these labels. I'm making you put these labels there so you understand what numbers are which. So you're learning it. Alright, so it says create a function map. Which number is my input? The negative 4 or the 4?
Negative 4.
So I'm gonna put negative 4 and its output is 4. Draw an arrow to it. Which number is my input? Negative 3. Do we already have negative 3 written down in my input?
No.
No, so write it down. And what is my output?
Negative 3.
Negative 3. Do I already have negative 3 in my output?
No.
So write it down and then draw your arrow. Which number is my input?
Negative 4.
Input,
Negative 2.
negative 2. Do I already have negative 2 written down?
No.
No. So I'm gonna write it down. What's my output?
Positive
4. Do I already have it written down?
4. Yes.
So do not write it down again, just draw your arrow to the other 4. Are we okay with that?
Yes.
What's my input?
Positive 4.
Positive 4. Do I already have positive 4 written down?
No.
So I'm gonna write it down. What's my output?
Positive 4.
Do I already have 4 written down over here?
Yes. No.
So don't write it down, but just draw your arrow to that 4. And I guess my ovals weren't big enough. What is my input for the last ordered pair?
5.
5. What is it? Oh, did I already have 5 written down?
No.
So I wrote it down. What's my output?
Negative 2.
Negative 2. Do I already have negative 2 written down?
No.
So I'm gonna write it down, draw my arrow. Is the relation a function?
Yes.
Yes or no?
Yes.
Brendan?
Yes.
Yes, he's absolutely correct. So write down and explain why in a moment. Look up here. In order to find out if a graph is a relation, there is a cheat that you can do without having to write the ordered pairs down or writing a relation map. You can do what we call the vertical line test. A vertical line test. you see all the black dots?
Yeah.
When I take my vertical line and I go to this first point, how many points does it touch? One, function. Here, when I go to this dot, how many points does my vertical line touch? One, function. When I go to this point, how many points does my vertical line touch? One, function. When I go to this point, how many points does my vertical line touch? One, function. When I go to this point, how many points does my vertical line touch? One. That's a way that you can cheat and find out if it's a function by just looking at the graph. Go ahead, me too.